Algebra 2. Today we're going to learn how to solve radical equations. Here are your steps for solving. Step number 1. I need you to isolate the radical on one side of the equation. In other words, make sure the radical is the only thing you see on the left or the right of the equal sign. You may have to transpose a number or divide by a number in order to do so. Step 2. Pay attention to the index number. Raise each side of the equation to a power that's equal to the index. So if you have a fourth root problem, an index number of 4, you want to raise both sides of the equation to a power of 4 because those are inverses of each other, and it will allow you to get x out from underneath the radical. Step 3, once you do that, you're going to solve the remaining equation for the variable. Again, just use equation skills that you've learned from Algebra 1. Transpose, multiply, divide, whatever it takes to get x by itself. And step 4 is not optional. Step 4 has to be shown. You're going to check the answer or answers that you receive by placing them back into the original radical equation, as long as it's one that has a radical in it, I should say. Replace the numbers that you think are answers back into the radical equation and see if it works. This is so you can avoid what's called extraneous solutions, and that's a fancy math word saying sometimes the answers to your problem will not work, and so there are some questions where you may have a no solution. So we have to check. We won't know ahead of time. You have to check the answers in the original radical equation to see if they are valid. Right, so we're going to start with example 1. I have 2 times the square root of x minus 4 equals 10. Please notice that that minus 4 is not underneath the radical. Notice that also I have 2 being multiplied by the radical. I have an index number of 2. My radicand is x, and I have a 4 being subtracted. My goal is to get x by itself. First step would be me moving or transposing the negative 4 to the other side. So you would show underneath this step, 2 times the square root of x is equal to 10 plus 4. Then you would get 2 times the square root of x is equal to 14. Okay, so your first step is a transposing move. When you get to this step, you now recognize that 2 is in front of or being multiplied by the radical. To do the opposite of multiply, you would divide. Divide both sides by 2. 2's will cancel. It will leave you the square root of x is equal to 14 divided by 2, which is 7. Okay, so the steps that are currently on the board all go back to step 1, which says isolate the radical. Get the radical by itself in front of the equal sign. So I had to transpose the 4 first, and then I had to divide by 2 just to do that. Step 2 in your notes says to now pay attention to the index number and raise both sides of the equation to the power that's equal to that. Since this is a square root, we would raise the left side and the right side to a power of 2. Recall from the past that a square root and a square are inverse operations in algebra, meaning they're opposites of each other. Taking the square root of something squared will give you that something back. So these two symbols kind of cancel each other out. You can think of it that way. And it's going to leave you with the radicand. And that's what we want to happen anyway. We're trying to solve for x. The right side says 7 squared. 7 times 7 is 49. So since this radical equation had just x on it, x the first, I would expect only one answer. If it had said x to the second, I would expect 2 answers. X to the third, I would expect 3. So the power on x indicates how many solutions you could get. Looking back at my notes, I've solved the remaining equation. I now think the answer is 49, and so the last thing I need to do is check it to see if it works. You're going to show your check somewhere on your paper, but you have to check it in an equation that has a radical in it. So I'm going to highlight your possibilities. You could check it in the first one, in the original one. You could even go with this one because it still has a square root in it. You could go with this one, or you even could go with this before I squared it. So you actually have 4 choices, and you get to pick which one that you want to use. You're going to put 49 in place of x and see if it works. With the 4 that I have highlighted, this one looks the easiest to me, so I'm going to choose that one. So I'm going to recopy this part. Again, that is a radical equation, and I'm going to take 49 and plug it in here and see if it works. And so I'm looking at the principal square root. The positive square root of 49 equals 7, and the answer to that is 7. So since 7 is equal to itself, obviously, then this is the right answer. So remember, the check has to be shown. So 49 is my solution to this problem. Question 2. The square root of 2x plus 3 minus 7 is equal to 0. Notice that this is a square root, that the radical goes all the way across and ends at 3, but this 7 is not underneath the radical. My goal is to solve for x. First, I would need to transpose the negative 7. Zero plus 7 gives me 7. Next, I've got to get rid of the square root. So I'm going to look at the index number and raise both sides to a power that's equal to that, which would be 2. This part, which is the radicand, is the part that's left. The square root of 2x plus 3 squared will give you 2x plus 3. So since the 3 was underneath the radical to begin with, it just kind of has to stay on this side until you get rid of it mathematically. The right side is 49. Now notice that this step does not have a square root. It's just a linear equation. Very easy to solve. Again, your goal is to get x by itself. Now you need to move the 3. So 2x is equal to 49 minus 3. Two x is equal to 46. To get rid of the 2, you're going to show division. And 46 divided by 2 is 23. So you're going to put x is 23 for your possible solution. I'm going to go ahead and circle it, and then I need to verify or check to see if that actually works. So, looking at all the work you've shown, you now pick out an equation that has a radical in it. You can use the top one, you can use this one before I squared it. Whichever one you think is the easiest, you would write down. I'm going to choose the second one that I've highlighted. So the square root of 2x plus 3, and I'm looking to see, does that really equal 7? By me substituting 23 in x's place. So let's work on the left side. For the check, let's do 2 times 23, and then plus 3, and then equals 7. And so 2 times 23 is 46. 46 plus 3. Okay, notice this looks similar to the last one, but it's pure coincidence here. But the square root of 49, you have to simplify that. That becomes 7, and 7 does equal itself. And so the answer to this problem is 23. Okay, question 3. 3 plus quantity 4 minus x raised to the 2/3 is equal to 11. This time, instead of me using a radical, I chose to use a fraction power because we should know already what that means. We can switch it over to a radical, and that way we can perform the same steps. So notice again the 4 and the x are both inside parentheses. I'm going to go ahead and write my radical symbol down and put 4 minus x underneath it in parentheses. The 2, actually the numerator stays with the base, so this is going to need to be a 2 underneath, and the denominator is the index. So when you have a fraction power in an equation, go ahead and change it over to radical and then follow the same steps. Okay, our goal is to isolate the radical, get this by itself in front of the equal sign. To do so, I'm going to need to remove this 3, and it's a positive 3. So in the next step, I'm going to show that I have transposed it. We'll drop down the cube root of quantity 4 minus x squared is equal to 11 minus 3. Okay, next I'm going to drop this down again. And that's going to give me 8. The next step, again, all of this is still underneath that radical, so we got to get rid of the cube root. Index is 3, so this time we're going to raise the left side to a power of 3 and the right side to the same power. The cube root of something cubed is that something back, so like all of this will need to come down. And don't forget your power of 2 there. Can't get rid of it yet. And then 8 to the 3rd, 8 times 8 times 8 is 512. Remember the goal every single time. All of these problems is to solve for x. So we got some work still to do. We need to get rid of this big power of 2 since it's outside these parentheses. So you now do the opposite of squaring. The opposite of squaring is taking the square root. And so you are going to have to do that on both sides of the equation. Okay, now that I've done the square root, I have the square root of something squared. Well, that something comes back. And so that's going to be that 4 minus x. So we finally got rid of the power of 2, which is good. Recall from the past, if you're dealing with equations and you take the square root of both sides, there's actually 2 answers. Also, the power of 2 on the x should have indicated that. So remember to put that little plus minus, because if you don't, you're going to lose an answer. When you're dealing with an equation, I'll repeat that, an equation, and you take the square root, you make sure that you write down both positive and negative answers. I'm going to go ahead and use 512 and then try to figure out if I can simplify it, and I can write it a different way. 512 is divisible by 4. Now I'm checking 9. It does not work. Let's check 16. 16 does work. I need to keep going though. Let's check 36. 36 does not. Let's check. The next one would be 49. 512 divided by 49 does not work. 512 divided by 64 does work, but it's an 8, so let me keep going. 512 divided by 81 does not. 512 divided by 100 does not. Divided by 121, no. Divided by 144, no. To keep going, we have to find the biggest one we can. Five, 12, 256. Okay, so I had to go all the way up to 256 to find the highest one. 256 is a perfect square, so we're going to write that as 256 times 2. And notice it took me a while to find that. Okay, I'm going to go ahead and simplify the right side. Moving down to the next step. The square root of 256 is 16, so we're going to pull that out in front. And then the 2 is going to stay underneath the radical. Now, I still have this 4 minus x over here, and remember my goal the whole time is to solve for x. So the next step, the 4 is being added. Make sure you pay attention to the sign in front of it. That's going to need to be transposed. The negative is attached to the x, so it becomes, drop it down, negative x equals positive negative 16 radical 2 minus 4. We can't subtract 16 radical 2 minus 4. So we're going to come back over here. We see a negative 1. It's being multiplied. So we're going to divide by negative 1. Alright, and essentially what that's going to do is just change the signs of both. So this is what we're looking at. A positive 16 radical 2 plus 4 and a negative 16 radical 2 plus 4. And if you want to give a decimal answer for those, you can do that. You can type in 16 square root of 2, add 4 to it, and you get 26.6. Excuse me. On the second one, type in negative 16 radical 2, and then add 4 to that, and you get negative 18.6. So either one of these answers is acceptable. And then your job is to go back and now plug it in. You got to check them. You got to see if it works. So since I'm having you check these, as we have to actually to see if it is extraneous, it honestly might be easier for you to just give me the decimal. And that's okay. So when you go back, you have to pick an equation that has a radical, either this one, or this one, or this one, or this step, or even this step. Okay? No, not the last one. Let me take that off because I was wrong there. So I'm going to have to go with, it looks like this, I got 4 choices. I'm going to go with the last one because it looks more simplified. So I'm going to go to the side and write down the cube root of 4 minus x, quantity squared, is equal to 8. And what you'll have to do is you'll have to go back down here and pull one of these, you got 2 answers, and you got to check both of them. So you now have to do this. 4 minus that was 512, wasn't it? Square root of 512. Square it, and equals 8. And then you can use your calculators. Type all this in, cube root it, see if it works. But then remember, you also, because there's 2 solutions, you have to try the other one too. Okay? try the other version. I'm just going to write it down for right now and see if you get 8 on that. Okay, and that way you'll know if both of them work or if one works. Sometimes that happens. Sometimes one will work, and if that's the case, like let's say this one worked and this one didn't, you put a big X on this one. If both of them don't work, then the whole problem is no solution. So be careful and make sure when you're checking those that, like I said, if you get 2 answers, that you check both. Okay, so the whole purpose is to solve for the variable using your steps that I shared with you on the previous slide. Just make sure you check it.